All right, lesson 6 is all about practicing and using the Python tools and ideas that we've introduced already. So no new material there. We will introduce or reinforce some of the things that you may have remember or may not remember from the past from your calculus class. But what we want to do is we want to compare integration techniques, numerical integration techniques, to each other, basically. And so we're going to use this decomposition business. So really the overall problem, and we'll state it probably next lesson, is to create a program that compares and contrasts 4 different integration techniques. And I'm going to cover today, or at least in this little small video here, hopefully small video, all the 4 integration techniques. And so let's just start with the left-hand rule, because that's probably the one that you learned first. And what is the left-hand rule? Well, it means we're integrating this function f of x. So maybe this is your function f of x here, and we're integrating it from x0 to xn. Usually that's a to b, but in this case we'll just let it be x0 to xn, and we're going to break this a to b. So I can say that's going to be a, and this guy is going to be b, and then we're going to break this thing up into n intervals, or n plus 1 numbers. So we're going to break this sucker up. This delta x is going to be the same for each one of those, and we're going to utilize these little rectangles in order to estimate what the area is underneath that curve. So the left-hand rule just simply states that in this interval here, the first interval, I'm always going, or at least I shouldn't say first, but all of the intervals, every time I come to an interval, I'm going to use the left number for the height, and that's all we're doing there. So that becomes the height, and you can see the amount of error that's associated with that first interval. The second interval, again, left-hand number, right? So it'd be x1 in that one, and you come up here and we use that in height. And the problem is, well, the thing that we need to think about here in a few minutes is what happens when we come to this last interval. Well, I need 2 numbers in order to be an interval, so you end up using the left-hand one, which is the x minus 1, and you don't really use f of xn at all. So we'll get to that here in a few minutes, but basically you take that height, each one of these interval heights, and you multiply it by delta x, and we'll come up with an equation for some of these here in a few minutes. Actually, I think the only one that I do is the left-hand rule. So let's go to the right-hand rule. So if you pull up the right-hand rule, it's the same idea, except this time I'm in this interval here, and I'm just using the right number, the right-hand number. In other words, the biggest number of the 2, and that becomes my height. And you can see the error now is above the line. The area here is again above the line. The area on this side, while the function's coming down, then the error becomes underneath the curve. So again, same idea, multiply the height by the width, where this is delta x, and they're exactly the same for each one of these, because we broke them up into the intervals are all equal, and we can get that number. So that's another pretty easy equation that we can get. The next one is not as easy. The next one is called the trapezoid rule, and I don't know, maybe I need to pull out or underline or do something, but it's called the trapezoid rule, TR for short, I guess. And it's the third thing that we talk about. And all the trapezoid rule does is it uses a line, what's called a Lagrange polynomial, a P1 Lagrange polynomial, because it's just a line. So it's just a line that connects those two. And then all we do to find this y0 plus y1 over 2 is we integrate. And we'll see that here in a second. Yeah, we'll see it here in a second. We'll pull up the Python code in order to do that, or at least to look at it. So that's x0. This is x0 comma y0. This one's x1 comma y1, and then so on and so forth. And then if you actually took that line, right? So this line right here, and integrated it in the very general sense from x0 to x1. So this would be the very general line right here, and I took that and put it into P1x. You would actually get this equation times delta x. So y0 Or what is delta x? X1 minus x0. That's another way to say delta x. So that's what we'll see here in a few minutes. We're gonna put that sucker in SymPy and let it do its thing. So I'm gonna put this thing right here in SymPy, and then we're gonna see that this guy falls out. All right, so that's integrating a line over an interval. Now we get a little bit trickier. We integrate a quadratic. So that's this P2, this other Lagrange polynomial. So we're going to use another Lagrange polynomial. This is my x, and this would be a quadratic. So this polynomial here, actually, yeah, this polynomial is defining a quadratic function. It's going to go through the x0, so x0 comma y0. It's going to go through that point, which would be xm comma ym, and it would go through this point as well, which would be x1 comma y1. If this were my x0, this were my x1, and then we're gonna define xm as the halfway point. So it's x1 plus x0 divided by 2 is equal to xm. And then ym is just, I probably defined that over here. Yeah, I defined that over here. So it's just these two pieces right here. All right, so we're going to put that in SymPy as well, and we're going to come up with what that sucker is equal to here in a few seconds. And then finally, so the question is, well, what do I mean by an interval? So I just gave you an example here, and I'm using the left hand, so I'm using the left-hand rule. And I just wanted to give an example to show why one of the numbers ends up, we're not going to use one of the numbers. So in this particular case, we're going to use the left. You can see that we're using the left side, right? So I'm using the left. So I'm using the left side as my height, and then I'm just multiplying by delta x is 1.5. So f of 1. So we're putting f of 1 in and getting this number. And that's where this f of 1 times delta x. So that would give me the area of that rectangle. And then f of 1.5, which would be the whatever height that is, and then times delta x, and so on and so forth until we get an estimate, right? So I got 1, 2, 3, 4 different intervals and 4 different rectangles that we're adding up. And that corresponds to 1, 2, 3, 4 different rectangles. And then, so just notice that we don't use f of 6. So I guess, that's really the question is, what about f of 6? When would we use f of 6 and maybe not f of 1? Well, if we were doing the right hand rule, then we would use f of 6 and not f of 1. So think about that for a second. And why is that? Because then all that we care about is this, and that would be my height. Here, let me draw it in a different color. So I would be worried about this, and then my right hand would go over on that side, and then I'd be worried about this one, and I'd be going that direction. So it's the same, you end up getting the same rectangle, but moved over one. Let's see, it'd be this one going this way, so that one's moved over one, and then the final one would be whatever f of 6 is, and I don't think I defined what that one is. So that is the new one. So again, one of our numbers ends up dropping off, and that's really the only thing I wanted to point out here is if I'm given a start of 1 and a stop of 6, and I divide this thing into 1, 2, 3, 4 intervals, then I'm going to have 4 intervals that are 1.5 width. And I'm only in the left and the right hand rule, I'm only using a certain number of those. That is true with these as well, right? Because I'm given, so I can be given 1, 2, 3, 4 numbers, but if I'm given 4 numbers, I'm only finding 1, 2, 3 intervals. So I guess that's the part, is I just wanted you to realize that the total numbers that you're given, you need 2 numbers in order to make an interval, and that's what we end up doing in the code. So you have to actually code that sucker up. So So let me take this and put it to the side and bring up Python. And let's see. So this would be my first. Let's see if we can move this out of the way or move it over. It's not letting me move it. So let's just pull up this and hit F9. And when we do that, we get this result here. Now, first of all, let's look and see what that is. That's x minus x1. I guess I could have pressed enter here to see what that is actually. And we can move over. So what I'm doing is I'm using SymPy to integrate, and I'm integrating. So if you look at this equation here, this first piece, that should be the same thing that's in this first expression here. X minus x1, x minus x1, x0 minus x1, x0 minus x1 times y0, and then plus, and then you'll see the stuff at the bottom. And then what is this business? This is all about the integration. So I'm going to integrate with respect to x from x0 to x1. So that's this integral down here. I'm integrating with respect to x from x0 to x1. And when we do that, and when we tell it to simplify, we get this guy right here. So what does this guy represent? Well, it's this weird minus sign comes out here. Not sure why it does it all the time, that you always get the minus sign here. But if you flip these two around, so if you bring in the minus sign into this parenthesis, you get a minus x0 and a plus x1. So x1 minus x0. So that's exactly what we get here, and that's basically delta x. So y0 plus y1 divided by 2 times delta x. That is what I wanted you to see. And then the final one down here, this guy, is the exact same. Here, looks like I tried to. All right, so we have to make sure that we understand this is xm. This is the x01 is an xm, and then let's move over. And we're doing basically the same thing. This first term represents the first term in this one. So if you put your finger on it and sort of roll through x minus x0, 1. Yeah, x0 being one of these two numbers. Yeah, I guess I could have done the notation a little better for this one. Yeah, I probably should have done the notation a little bit better, but let's see what this thing gives us. So if you go F9, yeah, hold on. Oh, I had to come up here. All right, so if we do that, we get this guy. So it ends up being x1 minus x0, and then y0, and then instead of ym, I used a y01 and then y1. So you can see how this thing's written out. Okay, that's all I got for this one. I know this was maybe a lot more math than we're used to. I just needed to at least show you where these things come from, and we'll start using them next time.